Hi, welcome to Essential IT and Security Skills. I'm Charles Redman, Master Trainer, here to guide you through the essentials that you are going to need to land the job that you are looking for. In this series, we're going to talk about essential PC skills. I'm going to walk you through everything from software to hardware. Most people know me as a cybersecurity expert. Well, I couldn't have gotten there without learning the basics first. That's what this series is going to do. And then we'll move on in some later series with some more advanced concepts and techniques. But remember, it all starts with the basics. It starts right here, the essential PC skills. In this segment, we're going to talk about virtualization. I'll describe the basic concepts behind virtualization, explain why PC and network administrators have widely adopted virtualization, and describe how virtualization manifests itself in modern networks. Virtualization is often called the next big thing. Virtualization creates a complete environment for a guest operating system to function as if it were installed on its own physical computer. Guest environments are called virtual machines. Individual machines or entire networks can be virtualized. So, what is virtualization? Most people have heard of virtual reality. Just think of the Matrix. A virtual world is created by software, with sight and sound provided by video and audio equipment. Primarily, it's used for gaming or flight simulations. However, with some special equipment such as goggles or special gloves, it can enable you to see and move virtual objects. Computer virtualization is fairly similar to that. It's a virtual operating system. The software computer, the guest, is running on a piece of physical hardware. That's the host. It allows multiple different operating systems to run on a single physical host. So, as I mentioned, both computers and networks can be virtualized. Virtualization convinces the operating system that it's running on its own hardware. The virtualization software runs on the host operating system, the physical PC, and the guest operating systems are virtual machines. Virtualization uses what's called hypervisors or virtual machine managers, depending on the vendor. Microsoft uses a hypervisor. So the host operating system uses a program called a supervisor. It handles the very low-level interaction amongst the hardware and software, like task scheduling. Full virtualization requires an extra layer of programming to manage all those complex interactions. This is where the hypervisor or virtual machine manager come in. The hypervisor handles the input and output requests an operating system would make of a normal piece of hardware. It allocates real hardware, such as the drives and RAM, from the physical host machine to the virtual machine. This enables easy addition and removal of virtual hard drives and virtual network cards. So you'll hear a lot of strange terms like emulation or virtualization. They sound the same, but there is a difference. Virtualization uses hardware from the host system and divides it into individual virtual machines. It basically abstracts hardware that runs on the same platform. However, emulation is very different. It enables software written for a different platform to run, but it does not virtualize the hardware. An emulator is software or hardware that converts the commands to and from the physical host machine into an entirely different platform. For example, an emulator makes it possible to run game console software on a PC. So these next few slides are going to take you through a quick tour of virtualization. In this example, Windows 7 is going to be the host operating system, and I'm going to be using a piece of software called VMware Workstation as the virtual machine manager, and the Linux distribution Ubuntu is installed as the guest operating system. So to get started, you're going to need to obtain a copy of VMware Workstation. This program isn't free, but VMware will give you a 30-day trial so you can try out the features of the product. After you successfully download and install VMware Workstation, now you're ready to install your guest OS. When you first fire up VMware, it's going to greet you with the standard welcome screen where you'll be able to select a typical or custom setup. Next, you'll have to select what type of installation media you're going to use, whether you have the physical installation disk or if you have an ISO that you have downloaded from the internet. Next, you'll need to decide exactly how much virtual space to give your guest operating system. And then you need to give it a name. At this point, your screen will begin to look exactly like what your screen would look like if you put the same operating system install disk in your physical machine. You'll start to see, in this case, Ubuntu installing just like it was on a physical computer. Once complete, you can now go and take a look at your brand new operating system in the VMware Guest Management tab. Here you see I have a single VM named Ubuntu. First, the virtual machine manager will kick in. That's the VMware splash screen going through its post process. So why do we virtualize? Virtualization provides two key benefits. It reduces the number of physical machines required, and virtual machines are simply files that make it easy to manage backups and patch and security. Some other reasons to virtualize is power savings and hardware consolidation, as well as system recovery and system duplication. So before virtualization, each server operating system required its own unique physical system. Now, with virtualization, you can place multiple virtual servers on a single physical system. That reduces the overall electrical power requirements for the organization. Also, the physical high-end server represents a substantial investment in hardware for most organizations. You're talking multiple processors, RAID arrays, and redundant power supplies. With virtualization, it makes it possible to increase your overall RAM and run a number of servers on a single machine that otherwise a small organization probably could never afford. Probably the most popular reason for virtualization is to keep high uptime percentages. If a system goes down, you need to quickly restore that system from a backup. With virtualization, it makes it possible to shut down the VM and reload an alternate copy almost instantly. So, like I said before, VMs are simply files. Files can be copied, and when you can copy a file, you can mass duplicate them. So now, if you have an organization that needs to roll out 100 or 1,000 physical computers, that could take days or weeks or months. With virtualization, you can do it in hours. Another key benefit to virtualization is research. Virtualization makes it possible to reduce the number of research and testing machines required for advancements in technology. It has actually streamlined the amount of equipment necessary in things like product testing and security testing, as well as development testing before they go into production. So let's take a look at virtualization on some of the modern networks. So far, we've discussed two products: VMware Workstation and Microsoft Virtual PC. These products are suitable for small implementations with few virtual machines. However, large-scale implementations require a bit of a different approach. For a large-scale deployment of a virtualized network, you're going to use bare metal hypervisors. They have no operating system required, and the virtualization software is the OS itself. This was accomplished by VMware when it introduced the ESX in the early 2000s. It has a very small storage footprint and can be installed on and booted from a USB drive. Next, you're going to need something to manage all of these virtual machines. The Virtual Machine Manager is virtual machine software that runs on top of the host operating system. Remember the example I showed you with VMware Workstation. Well, a hypervisor is software that does not need a host operating system. For VMware, that is referred to as the ESX server. When choosing a virtual machine manager, there are many choices to choose from for Linux, Windows, as well as Mac, whether they be VMware Workstation, the Microsoft Virtual PC, or Parallels. By far, VMware is the industry leader in virtualization and comes in versions for both Linux and Mac. They also offer features such as VM tools that make interactions between guests and host OS practically seamless. Microsoft's Virtual PC is a free product. However, it does have some limitations. Officially, Microsoft supports Windows VMs. However, Linux VMs can be installed and managed with Microsoft Virtual PC. The most popular virtualization manager for Mac is a piece of software called Parallels. It supports all the popular operating system and even has a pretty good 3D graphic support. Here you see it turns my Mac into Windows. And next you have a product called KVM. It's an open source virtualization product that is supported by the Red Hat organization. There are a few other open source contenders out there like Zen and Oracle's VirtualBox. I would recommend you give each of them an opportunity and learn how they work. So while there are several choices when it comes to virtualization, there are two dominant in the market. That would be VMware's ESX and Microsoft's Hypervisor V. The ESX hypervisor provides support for large SANs and NASs and is transparent and pretty much automatic when it comes to fault tolerance. It offers support for up to 32 CPUs. Of course, that's depending on the version. With Microsoft's Hyper-V, it is, again, a free product. Previously, it was only part of Windows Server 2008, but now it's available as its own standalone product. It also provides support for 64-bit systems. There you have it. It's pretty simple. Remember, everything starts with the basics. Once you have these understood, everything gets a whole lot easier. If you have any questions or even just a comment, feel free to leave them below, and I do read each and every one of them. I'll see you next time.